How's it going, everybody? In this video we are going to go through the introductory video of Ospf. And let me start off with to set your expectations for Ospf. Now, I don't know if you can see the little icon over here that is the drag bar, but if you notice, it's actually really small. I took a ton of notes with Ospf because Ospf, unlike EIGRP, RIP, and BGP, is a monster of a protocol. Now, I don't want to scare you, but I want to set your expectations that when we go through Ospf, we're not just going to cover the little nitty-gritty details of it. We're going to jump off the deep end, because Ospf, if you don't understand it in detail, you can run into a lot of issues. So I want to let you guys know out of the gate what we're going to be talking about as we go through and breaking down Ospf, because it is like I said, it's a monster of a protocol, and if you don't completely understand what you're getting yourself into, you can quickly and very easily run into issues through your deployment or through trying to understand how it goes. And you can use this entire set of videos as a really good base for you to build upon on your CCIE level prep if you choose to go CCIE. So we're going to go through the basics of Ospf in this video, cover what all the details are, and then we're going to run into some of the more complicated things as we go along. So be prepared. It's going to be a lot of material. Simply stating from the last route videos that I put out compared to these ones, this route series is going to blow the previous one out of the water. So, what is Ospf? Ospf is the Open Shortest Path First protocol, and just as a top note here, it says designed to route to the node that owns the attribute that is the prefix. Finds the shortest path to the node you have found the shortest path tree to the prefix. So basically, Ospf finds the node, will route to the node that owns the prefix, because a node is just a point on a graph, and Ospf graphs out the network. So that's what the SPF algorithm is for, or the shortest path first algorithm. So, a couple of recommended resources before we get started. Ospf Anatomy of an Internet Routing Protocol and Routing TCP/IP Volume 1, both great reads. Read them both for Ospf, and there's a ton of really good information on them. Also, I would highly recommend you, at least for CCNP, read over some of the RFC for 2328, which is Ospf version 2, or 5340, which is Ospf v3, and check that out. But my recommendation would be to make sure that you understand how it works from a fundamental level and take it from there. Documentation-wise, from Cisco's site, tech guides, so the technology guides or the configuration guides and the command references, there are a lot of caveats with Ospf, as you'll find as we go through here, and you'll quickly find that as we're going through, there are some details that aren't highlighted in Cisco's documentation that you need to be aware of. We will cover those as we get there. It is an open standards-based routing protocol, meaning you can run it on multiple vendors. Ospf v3 routes both IPv4 and IPv6, as there is multi-address family support. And RFC 2328 is strictly IPv4 Ospf. Now, let me be clear on something real quick. Ospf v3, if you're running Ospf v3 IPv4, that is not compatible with running Ospf v2 on another router. So if you have router 1 and router 2, and you're running router Ospf 1 on a particular for that particular router, and then you are running Ospf v3 IPv4 process ID 1 in area 0, and they're both running in the same area, they are not compatible with each other. You cannot form an adjacency with each other. So you'll find that there are some caveats with running Ospf v3. So we'll get into those as we get along, and I know Cisco's made some changes to some things, so we'll talk about that more or less when we get farther along with this, but it is pretty straightforward for the most part. It's a classless link state protocol, meaning it uses Dijkstra's SPF algorithm, and it maintains active adjacencies. There are some limits to design and traffic engineering that we'll cover, but for the most part, it's relatively straightforward as long as you know how it works. It does support variably length subnet masks. It's a classless routing protocol from out of the gate, and it supports both topology and NLRI summarization. And we'll talk about that more in detail when we actually get into how summarization would work. And it guarantees a loop-free topology. All routers agree on an overall topology in the same area. Not this, if you're crossing areas, you're going to be using an ABR to reach that next area, and then from ABR to ABR, it routes based on it's like a distance vector routing protocol. So basically, it goes based off on a hop count. So we'll take a look at how that would work coming up later on. There is an SPF calculation for intra-area routes, and you're going to leave your area, you're going to find the shortest path to the Type 3 LSA. But we're going to, like I said, we're going to talk about that in more detail later on. It is a standards-based routing protocol, like I mentioned, so you can run it between Juniper and Cisco, or Cisco and Fortinet, or Cisco and somebody else, or Fortinet and Palo Alto. So those capabilities are there, and depending on how you're doing things, it does scale well. There is large scalability. It is hierarchy through areas, so you can go in and build your areas out. So you can do area 0 as the backbone, and you can have several areas in between. So you can have area 1 peering off route to peering off area 0 to break down what's going on inside of area 1, and then you can do topology summarization. So you can do do things like stub areas and totally stubby areas and not so stubby areas and totally not so stubby areas and things like that. And we'll talk about that more in detail later on. Fast convergence, it actively tracks neighbors, and it uses an event-driven incremental updates. Basically what that means is it does what they call ISPF, or incremental SPF, meaning that if you have a single update coming in, it's not going to run SPF on all routes, just the one that's coming in. So we have some benefits going on there. And then we have fast SPF efficient updating. Oh, actually, that's where this one belongs. Bam. And then we're going to have, it is IP protocol 89, and it uses reliable multicast and unicast updates. So non-OSPF devices do not need to process updates, and we'll talk about that in. Not sure what that means. Non-OSPF devices. Oh, if it's not running OSPF, he doesn't have to worry about the update. Bandwidth is based off of a very, very easy to follow cost metric. So more flexible than static hop count like RIP. It does offer control plane security. Supports multiple forms of authentication: clear text, MD5, SHA, and IPsec. As we get into OSPF 3, you'll get into IPsec, where you can do one-hop IPsec tunnels between your routers to completely encrypt all the data. And it is extensible. So future applications support through the opaque LSA and MPLS traffic engineering. So it's pretty straightforward for the most part. So now that I've gone over a high-level overview of what we're going to be covering in OSPF, now we're going to get into how OSPF actually works. And this is going to be a bonsai detailed breakdown of how it actually works, because this is going to set the stage for the rest of this section. And if you don't understand how OSPF works, and I'm going to build it category on top of category on top of category, and at the end of this section, you should have a solid understanding of how OSPF works in detail. So I think you guys will, there will be a lot of benefit in my opinion. So what we have is step 1, you're going to discover your neighbors and exchange routing info. So that's when you're sending hellos, everything comes back, and you guys agree, you guys give each other thumbs up, and you start to exchange routing info. You choose the best path via SPF, and then the neighbor and topology table maintenance comes into play when routes get the LSA age gets too old. You can age things out. There is a paranoid update, which happens every 30 minutes, which is going to flood the entire SPF or Lsa database out to all routers, so that you make sure that everything is good to go. There's ways to disable that so that you don't have that happen, but that's only one. It happens every 30 minutes, so not too big. 1800 seconds is basically what it boils down to. So for step 1, we're going to break this down and go into detail onto each section as we go through. So for step 1, it uses a hello packet to discover neighbors on interfaces and able to run OSPF. So basically what this means is when you type in network whatever address, you're not, like with EIGRP, you are not going in and you are not advertising your route. You're simply turning the OSPF process on an interface that matches the network statement. So if the IP address on an interface matches the network statement, that is what you are going to you're going to enable OSPF on that particular interface, and that's how EIGRP works as well. We have since it uses transport via IP protocol 89, it's sent as multicast to 224.0.0.5 or .6 or as unicast. So the idea is with 224.0.0.5, that's going to be going to all SPF routers, so a non-DR or BDR router, and then we have .6, which is going to be our DR or BDR. And then if that doesn't work, we're going to send it as unicast. And where that comes into play is if you have a router as the DR. What's going to end up happening is all routers are going to send a multicast their updates to 224.0.0.6, and then what's going to end up happening at that point is the DR is going to receive them, and then it's going to unicast the updates out to all of the other routers, or it can multicast them depending on the situation. We'll take a look at that, how that would work coming up later on. The hello packet contains attributes that neighbors must agree on to form adjacencies. So you can form neighbor relationships, but not actually form an adjacency. So if you form an adjacency, you can you also form a neighbor relationship. So once the adjacency is set up, is negotiated, link state database is exchanged. And what they mean by this line right here is if you have the wrong, if you form a neighbor relationship but not form an adjacency, what this basically means is when you are peering with somebody, you can, for instance, with a DR and a BDR and a DR other, if you have 5 routers on a LAN segment, you're going to form a peering with the DR and the BDR with every router. If you have 4 routers, or the other 2 routers, what's going to end up happening is, let's say router 1 and router 2 are the DR and the BDR. 3, 4, and 5 peer with router 1 and router 2. Router 3, 4, and 5 are not going to peer with each other. They will go to what they would say as a two-way state. They'll go to two-way, which means that they have sent hello packets back and forth with each other, and they agree on at least the initial configuration. And we'll talk more about how the neighbors are actually formed, but the idea behind it is you can form a neighbor relationship but not actually form an adjacency. An adjacency doesn't happen until you start exchanging the link state database. Now, you can actually go to this extent. You can go in, you can form an adjacency, you can form a relationship, and then form an adjacency. And then once you when you form the adjacency, you can actually not install any routes. So if you have a network type mismatch, so basically if you when we get into the LSA types, we'll talk about LSA type 2, which is going to be the DR LSA. If that DR LSA is being sent by one router but not by the other, so it's network type broadcast versus network type point to point, they will form an adjacency, or a neighbor relationship. They will form an adjacency. They will exchange their link state databases. However, you will not route to the other guy. The link state databases will be exchanged. You'll go through all that part, but you'll get stuck at exchange, the exchange state. You won't go to full neighbor relationship. Now, why is that? The reason for that is because of the fact that you will have a network type mismatch. You have to make sure the network types match, and if they don't, you won't be able to run SPF and install OSPF routes into the global routing table or the GRIB. You will be stuck at the exchange state. Once you have made that adjacency change, SPF will be ran, and then whatever best paths are in the database that SPF is ran against will be installed in the RIB. So that's how that works. Now, negotiating OSPF adjacencies is pretty straightforward. Adjacencies occur when connected neighbors agree with unique or common attributes. So not all neighbors actually form adjacencies. We've already talked about how the DR and the BDR form adjacencies with everybody, but all the other DR routers only go to two-way. most OSPF configuration problems happen at this stage. You can have several issues that could pop up, and we'll talk about those as we get farther into troubleshooting adjacencies. So the unique router OSPF adjacency attributes, the router ID, they have to be unique. Node ID in the link state graph. You cannot have duplicate router IDs, or you'll get into what they call a flood war or a duplicate router ID war. It's chosen based off, and the router ID is chosen based off of manual configuration, and beats all of them. So router OSPF, or I believe it's router ID and whatever the address is. We have the highest active loopback IP address, or if there's no loopback, the highest active interface IP running OSPF. So we have that. Now with the interface IP address for OSPF, it's going to be the interface's primary IP address. For OSPF-v3, it's going to be the interface link local address for that particular link. It's not going to be somebody else. And then we have common adjacency attributes. We have interface area ID. We have the hello dinner interval. We have interface network address. Interface MTU. This is they're common, but the MTU can't be turned. You can actually disable that. The network type has to match. Authentication has to match. The stub flags have to match, and other optional capabilities as well. So now when we get into the OSPF hello packet, it gets actually starts getting kind of interesting here as to how it all breaks down. Router sends periodic hellos out OSPF enabled links every hello interval, which is every 10 seconds or every 30 seconds. The hello packet contains the local router ID, the area ID, the interface subnet mask, interface priority, hello dinner interval, authentication type, and password, and that's and the DR BDR addresses. Options, router ID of other neighbors on the link. So, if you hadn't noticed, this is much more complicated than EIGRP out of the gate. Now, what we're going to do is we're going to get into the OSPF state machine and make sure, the adjacency state machine, and talk about how this all comes into play. Now, the way this breaks down is we have down, which is no hellos have been received from a neighbor. Okay, down is meaning it has nothing's going on. We have attempt. Now, this is only on NBMA neighbors. Okay, when you're going over frame relay or you're going over ATM or something like that. Unicast, and unicast is the key word here. If you're using attempt, that means you're using unicast with a neighbor statement. So you unicast hello packet has been sent to neighbor, but you haven't received a hello back in. So a NIT and down and attempt are the same thing. Down is on a broadcast segment, and attempt is on an NBMA segment. So your encapsulation will dictate which way the OSPF will choose to go. Then you have a NIT via multicast. I have received a hello packet, or NIT and attempt and a NIT are the same thing. I apologize. I received a that's the next step. So a NIT via multicast. I have received a hello packet from a neighbor, but they have not acknowledged a hello from me. Now, the two-way state is where your DR other routers are going to stop. So I have received a hello packet from a neighbor, and they have acted a hello from me. This is indicated by my router ID and my neighbor's hello packet. So that you received a hello packet, or they receive a hello packet from you, they insert their router ID inside of an update, and they send the hello back to you. You see your router ID in their information, so you guys know you guys at least agree on that much. A list of routers on my on scene on my segment. I must have added in a word there. A list of routers seen on my segment. A list of router IDs the neighbor sees. So this is basically going to be an indicator of what's going on in your network. Issues at this point are indicated layer 2 issue, where you have a VLAN mismatch, or for a DELSI issue, or potentially even a MPLS LDP mismatch. Exchange start, first step of actual adjacency. So this right here is neighbor relationship. All this. Adjacency is this piece right here. Exchange start. This is where the master-slave relationship is formed. Where the master is the highest router ID, and we'll show you how this looks. Master chooses the starting sequence number for the database descriptor packets that are used for the actual link state advertisement exchange. Now with exchange, the local link state databases is sent through database descriptor packets. and the DBD sequence number is used for reliable acknowledgement and retransmission. Stub flags and other options happen here. So that's a good example of what's going on. So at this point, if you were to go in and have a situation where you get to this part where you don't get to loading or full, this is an indication where you have a potential problem with a network issue, and that can pop into play when something happens where you are going in and the network tables are wrong, or some other situation pops up and you're not exactly sure what the problem is. Network type mismatch is definitely a potential problem. I've seen that repeatedly, and we'll see exactly how that would look coming up. And then we have loading, which means link state request packets are sent to ask for more information about a particular LSA. Yeah, I'm reading most of these off, but I'm also explaining more in detail as to what I mean by them. So for the most part, pretty straightforward. And then we go to full, which means everything is synced and the databases are good to go. So, and then we go to step 2. That was all step 1. So step 2. So step 2 is pretty straightforward. Once databases are synced, path selection begins. Okay, so we've exchanged everything. Everything is going along. Now we need to run SPF on the link state database. So each router LSA includes a cost attribute for each described link. Best path to the lowest end-to-end cost. Multiple equal cost paths are allowed if via ECMP. Cisco implementation uses a bandwidth-based cost, but the request for comment for 2328 and 5308, I believe it is, says you can use whatever you'd like. Cisco uses the cost. And by default, it's 100 megabits over the link bandwidth. So what that means is, if using 100 megabits as the base bandwidth and you have a 10 megabit interface, that means that to take 10 and divide that by 100, it's going to be 10. If your link is 100 megs and you're dividing that by 100 megs, I mean it's going to be a cost of 1. Anything above that will always be a cost of 1. You can use the auto cost reference bandwidth command to change that. And then basically, once SPF runs over the link state database, those best routes are installed into their global routing table. At this point here, if you have the databases are synced, but you aren't learning any routes, nothing's being installed in the routing table, definitely a good chance that there's a network type mismatch or some other type of issue is you're being plagued. Maybe a stub flag is wrong. And then we get into step 3. Neighbor and topology maintenance. Once adjacencies are established and the shortest path tree is built, the Ospf state machine tracks neighbors and topology changes. Hello packets are used to track neighbor adjacencies, and LSA fields used to track topology changes. So LSA, if a new LSA is learned in, it will automatically restart the LSA time. So LSA time, we'll show you what that looks like. So if you receive an update in, that's going to indicate that there is a topology change, and the LSA time is going to reflect that. Tracking neighbor changes. Hello packets continue to be sent on each OSPF enabled link every hello interval, which is 10 or 30 seconds depending on the interface type you have. And this is indicated based off of the encapsulation in most cases. Now, if a hello packet is not received from a neighbor within that interval, the neighbor is declared down. Defaults to 4 times the hello interval. So you can use the dead interval, OSPF dead interval, minimum interval, something or other, where it's can do as less than 1 second reconvergence. I'll show you how that looks coming up. There's going to be a lot of OSPF level configuration at the interface level. We'll take a look at it as we go through, just so you guys understand what's going on. And then tracking topology changes. When a new LSA is received, it is checked against the database for changes such as sequence number, used to track the new versus old LSA, and the age, used to keep information new and withdraw old information. There's a periodic flooding that occurs after 30 minutes, and this is what I was talking about earlier as a paranoid update. LSAs reach a max age after 60 minutes are withdrawn, which means that if a new LSA hasn't been generated after 60 minutes, it's actually pulled from the link state database and it's done. And then a checksum is used to avoid transmission and memory corruption. So for LSA flooding, when a change is detected, a new LSA is generated and flooded out all links. OSPF does not use SH. I don't know what SH is. I'm not sure on that one. Self-originated LSAs are simply dropped because you originated them. SH. Not sure what that means. But anyway, not all LSA changes require SPF to recalculate. So, link up-down event, rerun SPF, versus sequence number changes, do not rerun SPF. And so, OSPF behaves like a distance vector between areas, so it does not have topology visibility end-to-end between areas, and we'll take a look at that as we go along. So that is a high-level overview of how OSPF works, just to give you guys an idea of how all these details are. So we're going to stop the video here, and then what we're going to be able to do in the next video is we're actually going to start forming adjacencies. And what I'm doing at the same time as I'm actually doing EIGRP and OSPF at the same time. So I do an EIGRP video, I do OSPF, and go back and forth. Obviously EIGRP will be released before OSPF will, but because EIGRP has a lot less to worry about and to work with. There is a question on the topology. Okay, the question is, am I going to do the frame relay configuration with the dynamic protocol like OSPF and EIGRP? Yes, I will. I will be running OSPF over this segment here, and I'll run EIGRP over this segment here. And what I will be doing after that is I will go in and I will, once I've gone over that and we have it deployed, I will actually pull both protocols back. So I will take them off of these links here, and then once we get into BGP, we'll run BGP over frame relay. And the question, can you run BGP over frame relay? You absolutely can. BGP is just an application, if you will, and it's a network. How can I put it? It's a network reachability protocol, and basically what it does is it just advertises routes. It doesn't worry about the next hop. So in our case, there had to be some underlying mechanism in place in order to guarantee the next hop. So that's what iBGP uses uses IGP for iBGP, and we'll talk about that coming up. And then you mentioned in a previous video that you'll be running DMVPN. Is that going to be running on top of BGP? And then what protocol would you use over DMVPN? I will be running BGP eventually over this, and because DMVPN comes after BGP will already be in place over both networks, over these guys, and then I run DMVPN over that. And DMVPN is just a networking, it's a routing technique. It's not truly a VPN technology. It allows you to run a overlay technology over your underlay. So it allows you to run multi-point GRE over your public internet. And what we'll be able to do then is run DMVPN over BGP. BGP will get us connectivity from 5 to 16 and 17. We'll run DMVPN over that, so our multi-point GRE, and then we'll be running OSPF over these links, and we'll do the exact same thing over here on these guys. So does that answer all your questions? Cool. For CCNP switch, will I be using live equipment or a simulation? I will be using live equipment for CCNP switch because it pretty much dictates that. There are some technologies out there, like in the lab, you'll be more than likely using IOU, or maybe not. I don't know. I haven't taken the new exams, but you'll be. When I took them, they were flash simulations, so I don't know what you're going to get. And they're graded automatically, and so as soon as you configure the correct things, you automatically are awarded the points. So you have that, and then from there, I will be using live equipment. I don't have IOU; it's a Cisco internal. Since you're asking about it, there is another way to do it with Viral, which is a way to do it, but I do have viral. I do have it running, but I haven't really had time to play with it. So, but that's pretty much where that sits. So, any other questions? What is your time frame to get more videos out? I actually deployed some videos tonight. So I actually put the first 7 videos out. So I covered anything layer 2 for routing. So those are already been deployed. And then we'll go into and get, as I complete more videos per section, I will get more out. So I'm doing the bulk of what I'm doing now, and I will be getting things like, for instance, we'll be getting like the network principles, that type of stuff will be coming out probably later than the routing protocols. There's some other things. I think what most people need to understand is that the route exam is very, very wide and very, very deep. And so with that being stated, I think it's a good idea for everybody just to get an idea as to what's going to be incorporated and to get a realistic idea of what's going on in the network. That I think will help out everybody. So I'm going to do my absolute best to put out a lot of videos that are really deep, and that'll help people out. But I can only do what I can do in the time frame that I've been given, and which technically is unlimited. I can take as long as I want to, but at the end of the day, I like to get these videos out as quickly as I can. So if there's any more questions, you guys can go ahead and toss them out. I don't see any more questions. So for those of you that are in my joining me live, I do appreciate your time. For those of you that are watching this in a recorded format, please feel free to drop me a line at my email up here, rraker82@yahoo.com. And beyond that, I hope this has been informative for you, and I thank you for viewing.